So as we discussed in the last session about the importance of creating a data dictionary, so we can understand what each of these values that we have on our model that represent. So we'll show each of these variables or each of these features with their description based on the research that I have made. Also to describe their data type. So let's start with the main features we have here is the age. Everyone knows what the age is, and the data type here is it's an integer type, which is a numeric. Next, we have the sex or the gender. We have categorical values, which is binary. One is male and zero female. Next, we have the CP. When we were saying that it's highly correlated with the target variables. So as you could see that it's more into categorical integer integer value. You have different levels here. The large is the maximum heart rate that were achieved, and it's numeric. We also have noticed that it's highly correlated with the prediction that we're trying to do. As you could see here, the heart rate and the chest pain is highly correlated. We also have the serum cholesterol in milligrams, also the serum. It's a calculated value represent the total serum cholesterol, LDL and HDL. Examine when an exercise, whether a patient has experience a chest pain when doing an exercise, comes on a shape of categorical value like yes and no, 1 and 0. We will might need to transform all of these categorical values into numerical values so we can make our model work on a more efficient way. It also has the fasting blood sugar, all peak depression just by exercise, literature rest, the target variables that this is our important variable whether a patient have heart disease or not based on diagnosis. It's also as categorical value. Yes mean 1, which he has heart disease. No means that the patient does not have a heart disease. So the target variable, you might hear me saying that it's a dependent variable. It's the same thing we are referring to. So this is our data dictionary. You might build your own data dictionary, which makes more sense to you, but I believe on at this stage, this is enough for us to move to the next step. So now after that, we have created our data dictionary and we have also identified the correlation matrix. Let's try to sort the highest correlated variables or feature with the target variable. Let's write the code and then I'll explain exactly how we can interpret each of these findings that we are going to get in return. So let's try to start with defining dependent variable is equal to the target variable in our case, target. Next, let's create a variable that will take the source so we can print it easily. It's equal to, you remember the correlation matrix that we have created earlier, which is this one? We're gonna use it. but we'll do some sorting on top of it. So matrix, and that has to take the dependent variable or the target variable. Now let's sort it in descending order. So we have to set this equal to false. And let's now print the correlation dependent. Let's now run this code. Correlation with dependent, correlation matrix, sort values as ascending. Okay. Let's run this now. And here we go. As you could see that, as we have seen before, that there are some several features has the highest correlation with the target variable, like the chest pain and the maximum heart rate were achieved, and some of them has also a high negative correlation with the dependent variable. For example, you have here is the exang and the old peak. So, for example, in the exang, it has a negative correlation with the target, suggesting that the lower maximum heart rate and exercise are related to a higher likelihood of heart disease. Also, the old peak, which is the depression induced by exercise, has the also one of the highest negative correlation with the target. So how do we read this? The negative correlation, we can say that, meaning that the old peak increases. As the old peak increases, the likelihood of having heart disease decreases. On the other hand, when we have the chest pain and the maximum heart rate that were achieved, as you could see that it has a positive correlation with the target. And the number that you have here, like 0.43, we call it the correlation coefficient. It suggests that it has moderate positive correlation between the chest pain and the heart disease. How do we read the positive correlation? In simple terms, as the severity of type of chest pain increases, the chances of individuals have like having a heart attack um, or heart disease also increase. As well as for the maximum heart rate that were achieved, which is the latch, which shows that it has a positive correlation. It has a correlation coefficient with 0.42 and a positive value. So in this context, means that the value of maximum heart rate increases the chances of having heart disease. So this is how we can read both of the negative and the positive correlation matrix with the target variable.